All right, so determine the peak voltage, the peak-to-peak voltage, the RMS voltage, and the half-cycle average voltage for the given sine wave. So this is the sine wave. It's not fully on grid, my apologies, but it is labeled to 6, okay? And the way you want to break this down is you want to notify what kind of graph this is, okay? So it's voltage. First of all, it says in the question as well, but this is the negative side and this is the positive side. And so for alternating current, you want to make sure that you have both, okay? And this is because it alternates between positive and negative values. Now, if this graph was raised up, okay, and there was no negative values or there was no positive values, okay, theoretically, it would not be an alternating current, okay? It would be non-alternating. And so to keep that in mind, we're just going to stay with AC circuits. This is going from positive to negative. And so to start with, let's do the first thing, right? Peak voltage. So peak voltage, if we know what peak voltage is basically, you can imagine a mountain. So the mountain, the peak of the mountain, right, is the top. And so what's the top over here, right? We can see it's clearly labeled 6, right? And sometimes it's not graphed, but in this case it is. Okay, so we can clearly write the peak voltage is 6 volts. Now that we have this value, the peak to peak, right, it's kind of in its name. It's the peak values from both sides, so the positive and the negative. So if we look at this cycle over here, the negative side's here and the positive side's here, okay? And so it should be both of these together. And so the formula that's given in most textbooks is 2 VP, okay? You may also see it as VP times 2, right? Like this, depending on your textbook, but they're basically the same thing, okay? And so if we plug in the values that we have, 2 VP, right, is right here, 6, so 6 volts, and that equals 2 times 6 is 12, so 12 volts. So the peak-to-peak value is 12 volts. And now for the more complex stuff, it's the RMS and average. And so for AC circuits, you have to remember 2 important details. There's a constant RMS value and a constant average value, okay? And so the RMS value is 0.707, okay? And the average is 0.637, okay? And these are all multiplied by the voltage peak or the current peak, right? The voltage and current are kind of interchangeable in AC circuits. And so for these calculations, okay, just want to specify that. And so this side would be VP as well. So these are the formulas that we're going to use to figure out these two values. And so if we plug and play these things, okay, let's do 0.707 times 6, okay, and then here, let's finish this off really quickly, and let's open the calculator, okay, have the calculator 0.707 times 6, okay, 4.242, okay, 4.242, and you want to make sure you're remembering the units we're using. So we're using voltage, and so we put a V. Okay. So now we have this. So this is the answer for the voltage RMS. Now for the average is 0.637, okay, and times 6, right? These are the same numbers here, right? This here, and so 6. Now if we get our calculator, we can do the multiplication super quickly, and we get 3.822. Okay, 3.822 volts. Okay, and so that is how you solve this question. And now if you want to get into the details, what RMS is, it's kind of it's the root mean, okay? So it's also used as the same heating effect as like a DC circuit. It's an equivalent. It's a root mean square. Sorry, I couldn't think about the S, but it's the root mean square. And so it produces the same heating effect as an DC circuit would, okay, as an AC. And that's why it's a constant that we use when we're trying to measure the AC circuits. And so, or a sine wave to be specific. And now for the average, right? The average, here it's specified, half cycle average. But if we do indeed use, or have a question where it doesn't say half cycle, okay, or it doesn't specify, it could be a trick, but what that means is when you're getting the average of two values, right? We're getting the average of this half and this half, okay? We're getting the average of the whole cycle. And so if you think about it logically, if all of these values equals to 100, okay? And then this is negative values, so this is negative 100, right? They're symmetrical in nature. And so if we add them together, you'll get 0, and so they cancel out. And so the average would be actually 0. But when we're dealing with the half cycle in this question, or in most questions with AC circuits, we're only dealing with half. Okay, so half of these values. So it doesn't cancel out. And so what we have here is this value over here. Okay, this is the constant that we're going to deal with. And that's kind of like a little rundown of how you should probably think about it, or some information about it. But to dive deeper into the questions, or to go to the final question, I should say, a sinusoidal current has an RMS value of 6 milliamps. Okay, determine the peak, half cycle average, and the peak to peak values. So what are we trying to find? So in this question, we're given these values so far, right? I'm going to switch back to white. And so what we're going to do is we're going to write down what we have. So we're going to represent that as current in a lot of circuits. And so RMS equals 6 milliamps. Okay, we have that written down. And now the peak value. So for the peak value, we can derive that value. It's kind of hard to do for the first time, but with experience, you'll get the hang of it. You want to refer back to the thing that we discussed before. Okay, so if we go over here, we have RMS equals to 0.707. Okay, so using this, we have the value over here for the RMS. Okay, so if we substitute the RMS value over here, right, and then we can rearrange for VP. So if we rearrange for VP, right, we have these two values. We just have to divide this side, right? Divide this side by 0.07, right? Sorry, dots here. And then divide this side, 0.7. So these two cancel out, okay? And then we'll get the VP by itself, and then we'll get this. And so now that we have this written down, we can refer back to our question and do the exact same thing, right? We have the RMS value. So how we're going to do this is we're going to divide this by 0.707. And then after that, we can do the calculation really quickly. 6 milliamps divided by 0.707. Okay. So it's 8.48 if we round to 3 sig digits. And so 8.49, and make sure you have the same units, milliamps. And that should be the peak value. So IP, right, equals to 8.49 milliamps. Okay, and that should be the first part of this question. And now for the second part. Let's scroll down a little bit. The average. Okay, so the average, what we know so far is that the average is 0.637, times IP or VP, right? And so in this circumstance, there's no need to rearrange, right? Here, I'll write it a little bit better here. So this is what we have so far. So now we have this value, right? So we don't need to plug and play. We don't need to rearrange, sorry. We can just plug and play. And so what we have 0.637 times 8.49. And then mentally, you can do the math, 8 times 2, right? Sorry, not 8 times 2. I'm just forgetting, I'm going ahead in my mind to the next question, but over here we have 0.637 times 8.49. For some reason, I just thought we were doing the peak-to-peak values. Okay, so we have 5.41, okay? So equals 5.41 milliamps, okay? Make sure you have the same unit, or you might get deducted marks and stuff, so make sure you have that. So this is the answer for the half cycle average. And now for the peak-to-peak, as I kind of slipped up before, peak-to-peak, remember if you refer back to the first question, is the value, the peak value times 2. So it's so this is the formula, and so over here the IP equals this, right? Sorry, IPP equals to this, right? So it's just 2, and then time 8.49 milliamps, and then 2 times 8 is 16, and then you can do 16 times 49. I mean 2 times 49, which is 98. So you can always double check this answer. I'm really bad at writing, honestly, but I'll rewrite this a little better. 16.98 milliamps. And so this should be the answer to the peak-to-peak, right? This is the answer to the half cycle average, and then this is the peak value right here. And so that's the entire video. Thank you for watching. I hope it was informative. And yeah, see ya. Bye.